This is section 11.6, derivatives of products and quotients. Last time we talked about the power rule, sum and difference rule, constant multiple rule, and other rules. Now we're going to be adding to those rules. The product rule says, let f of x equal u of x times v of x. Then what is the derivative? Well, we would hope that it would just be u of x times v of x, but u prime of x times v prime of x, but unfortunately that's not the case. Turns out that there's a pattern to this. F prime of x is going to be u of x times v prime of x plus v of x times u prime of x. Another way to remember this is the first times derivative of the last plus the last times derivative of the first. Now because they're multiplied and they're added, you can memorize this lots of different ways. There's lots of many ways you can memorize it. I'm going to stick to this way. Here's an example right off the bat. We have two functions which are multiplied together. There's a first function, there's a last function. It's okay if you call them u and v, a and b, whatever you want to call them. So let's see. The derivative is the first, 2x plus 4, times the derivative of the last, which is 6x, plus the last, 3x squared, times derivative of the first, which is just 2. Now we can simplify that. 12x squared plus 24x plus 6x squared. You can simplify, add like terms some more. Get 18x squared plus 24x. Now, quick note. Could I have gotten the same thing by foiling first, by distributing first, and then take the derivative? And the answer is yes, you can. But very quickly we're going to run into functions where that's not possible. You have to memorize the product rule. You have to know and memorize the product rule. It is not possible to get around it. Related to the product rule is the quotient rule. But of course, quotient means division. So this is when you're dividing two functions. Let f of x equal u of x divided by v of x. Then your derivative is v of x times the derivative of u of x minus u of x times the derivative of v of x, all divided by v of x squared. So another way to remember this is it's the bottom times the derivative of the top minus the top times derivative of the bottom all over the bottom squared. Please notice you start with the bottom, not with the top. A lot of people get that confused. You start with the bottom because subtraction, it matters which one you do first, which one you do second. So, here's an example we can practice. F of x is 2x minus 1 divided by 4x minus 3. So, the derivative is the bottom times derivative of the top minus the top times derivative of the bottom all over the entire bottom squared. A couple of pitfalls to watch out for here. Do not divide anything out. You can't cancel this because there's subtraction. Do not FOIL out the bottom. Leave the bottom alone. All you have to do is simplify the top. So let's see what we got. 8x plus 6 minus 8x, watch your signs, plus 4, all over, leave the bottom alone, 4x plus 3 quantity squared. Look at the top. Something wonderful happened here. 8x minus 8x, those go away. And you're just left with 10 divided by 4x plus 3 quantity squared. And that's it. Please do not mess with the bottom if you don't need to. So this isn't as bad as it seems. A lot of people are intimidated by fractions. A lot of people don't like the look of this, but it's not that bad. Here's an application. If the total cost of manufacturing X items is given by C of X, the average cost per item, the C bar, we call this C bar, is given by C of X divided by X, right? Average. You divide by how many things there are. The marginal average cost is the derivative of that function. Notice that this is C bar prime. C bar prime of X is the derivative of C of x over x. So here's an example. The total cost in dollars to manufacture X mobile phones is given by this function. Find the average cost per phone. Average cost is C bar. So you take this entire function, that's 50x squared plus 30x plus 4 over x plus 2 plus 80,000, and you divide the whole thing by x. So there's a couple different ways to write this. I would write it like this: 50x squared plus 30x plus 4 over x times x plus 2 plus 80,000 over x. Could we get a common denominator and add those together? Sure. I don't think it's necessary, though, to do that. Now, it also says find the marginal average cost. So let's take the derivative of this function. So that's c bar prime. That's the derivative of our function. So this is a long function. We're going to be here a long time taking the derivative of this. It may be worth it to go ahead and get that common denominator, add those together, so we only have one big fraction to deal with. So this is going to get complicated. 50x squared plus 30x plus 4 divided by x plus x plus x times x plus 2 plus, this is 80,000 times x plus 2. Take a look at what I did, and do you see how I got a common denominator by multiplying by x plus 2, and now they have the same denominator, I can add all the fractions together. Now all we have to do is combine like terms. I still have not taken the derivative yet. This is 50x squared plus, now, there's 80,000 x's, there's 30 more x's. That'd be 80,000, 30x. This is plus 160,000 plus 4, so 160,000 and 4 over x times x plus 2. Now we can take the derivative. So this is bottom times derivative of the top. So the derivative of the top is 100x plus 80,030 minus the top, which is 50x squared plus 80,030x plus 160,004 times the derivative of the bottom, which is itself a product rule, which I'm going to run out of room right here. So let me rearrange slightly here. When you need to move things, when you need to rearrange, don't be afraid to do it. Don't crunch it in, make it hard to read. There's no point in that. To make my derivative easier on the bottom, what I'm going to do is I'm going to rewrite the bottom as, this is an aside, x plus 2 is the same thing as x squared plus 2x. I'm going to rearrange it like that, so taking the derivative is just that. Over the bottom squared. So let's make sure we did this right. This is the bottom times derivative of the top minus the top times derivative of the bottom all over the bottom squared. All we have to do is simplify that. I'll leave that to you, dear reader. But this is all that needs to be done to find the marginal average cost. And I believe in the book they have you plug in some value to find out the marginal average cost of producing a number of cell phones.